Good morning to all judges. I am YI352. Today, I would like to discuss about our project named Biodegradable Fibre-Reinforced Radiant Barrier 2.0. According to the Europe Space Agency (ESA), manufacturers have produced different types of thermal insulator such as nylon polyester, bubble, and polystyrene insulation. However, all these commercial insulators are non-biodegradable and will cause harm to the environment when disposed. So, how can we overcome this problem? Well, in our project, we have designed this biodegradable fiber-reinforced radiant barrier 2.0 by using carbon fiber as an eco-friendly material to replace non-eco-friendly material. This is carbon fiber.
Moving on to the methodology. We have conducted 3 experiments to prove the effectiveness of the coupled fiber insulators. So, how can we know that our project is better compared to other commercial roof insulators? In the first experiment, we have compared the coupled fiber insulators with all other common types of commercial roof insulators, which are bubble insulators, polystyrene insulators, and uninsulated house model. In our second experiment, we would like to determine the thickness of the coupled fiber insulators will influence its effectiveness on thermal insulations. So, we have used different thickness of coupled fiber insulators, range from 0.2 cm to 1 cm in our house model. In our last experiment, we have compared the coupled fiber insulators with all other commercial car windscreen sunshades, which are nylon polyesters, aluminum foils, and unshielded car, to determine the effectiveness of the coupled fiber insulators.
Next, I will be talking about the results and analysis of our project. First, when the p-value is smaller than 0.05, that means there's significant difference. So, as you can see in our first experiment, the results show that the coupled fiber insulator achieved the highest average of the indoor-outdoor temperature differences on house models, which is 1.67 degrees Celsius. It also achieved the lowest p-value, which is 0.017. As for the second experiment, the coupled fiber has achieved the highest average of the indoor-outdoor temperature differences, which is 2.92 degrees Celsius. It also achieved a 10% low temperature, but its thickness is 1 cm. That means that the effectiveness of the coupled fiber insulator increased.
Now is for discussion. The different method of installing the roof insulation beneath the roof may result to various outdoor-indoor temperature differences on house models. Next, the experiment is we recommend to conduct in actual house with presence of occupants, appliances, and furniture, as it may slightly affect the efficiency of the thermal insulation. Then, the thickness of the coupled fiber insulators is not consistent throughout the whole sheet of the radiant barriers. However, this factor does not affect its efficiency in the thermal insulation. Lastly, the installing of the radiant barriers in the interior car roof as thermal insulation may be evaluated apart by windshield sunshade.
In conclusion, from this experiment, we have found out that carbon fiber is the most effective material for heat resistance. It is because carbon fiber contains 64% of cellulose, 13% of lignin, and 23% of pentosine, and it also contains waxy cutting on the fiber surface, which makes them water repellent, also known as hydrophobic, as well as they are oleophilic and biodegradable. Besides that, carbon fiber exhibits better performance and more heat resistance in thermal properties compared to any other natural fibers. Lastly, the material has a hollow lumen structure that traps a lot of air. This is because due to its hollowness, carbon fiber finds a place in the thermal barrier layer among all of the fibers. Thank you.